Hello friends, in today's class we are going to see the very important topic from first unit, that is multi-core CPU and multi-threading technologies, that will come under technologies for network based system in first unit. The first one is advances in CPU processors. The advanced CPU processors are having many cores, many number of cores, so this is called as multi-core architecture, and those multi-core architectures may be dual core, quad core, 8 core or more number of CPU cores. And in the year 1978 Intel was introduced the processor VIX 780. Those speed is 1 million instruction per second, and that the speed was increased in the year 2002, that is 1800 million instructions per second, the processor Intel Pentium 4, and the speed got increased up to 22,000 million instruction per second for the processor Sun Niagara 2 in the year 2008. And next very important thing is clock rate of CPU processors, and those reaches the maximum limit of this CMOS based chips. CMOS means complementary metal oxide semiconductors, due to the power limitation, because these CMOS chips will contains only 5 volt plus 5 volt DC plus 5 volt DC, and if you want to increase the clock rate means it should consume more power, and very few CPU chips will be very high speed which exceeds 5 gigahertz. If we increase the CPU power or CPU speed, that will generate more heat, that CPU will generate more heat, and the frequency will also very high, and it consumes more voltage. If it consumes more voltage, then the heat will be increased, so the CPU lifetime will be very much decreased. We are having different varieties of advanced CPU processors. Under this, the instruction level parallelism mechanism is one among them, which includes multiple issues: superscalar architecture, dynamic branch prediction and speculative execution. And this is instruction level parallelism, and this technique demand hardware and compiler support. And next one is data level parallelism processes and task level parallelism processes, which are explored in GPUs, that is graphics processing units, that adopt many core architecture. Many core architecture, many means hundreds to thousands of simple cores, that is those many tasks will be executed simultaneously in those processes. And now let us see the architecture of multicore processor. And this is the architecture of multicore processor, and in the multicore processor we are having n different cores, more number of cores will be there. For example, we can take n different cores are there in this multicore processor. Each core is having its own cache, each core is having its own cache. This cache is called as the private cache for this particular core. And likewise, all the core is having its own cache, and this cache is called as level 1 cache. This cache is called as level 1 cache, that is level 1 cache is private to each core. And on chip cache, this is on chip cache, and this is L2 cache, that is level 2 cache, which is shared by all the cores. All the cores will be shared this particular level 2 cache. And level 3 cache is there, and this is otherwise called as DRAM, and it is out of this multicore processor, and this is common for the entire processor, that is level 3 cache. So we are having three different levels of cache, Hence this is called as hierarchy of caches. Hierarchy of caches. This multi-core processor is using hierarchy of caches. First one is level 1 cache, level 2 cache and level 3 cache. Level 1 cache is private to all the cores. We are having n cores, means n different caches will be there, and one common L2 cache is there, that is called as on chip cache, and this is common for all the cores. And the external cache is also there, that is level 3 cache. This is placed outside the multi-core processor. This is common for the processor. And nowadays all the processors are high-end processors which includes the multi-core and multi-threaded technology. That is, all the modern CPUs are multi-core and multi-threaded CPUs, and these are some of the modern processors which are available in the market. Almost all these processors are multi-core and multi-threaded CPUs. Each core, that is in the multi-core processor, each core should also be multi-threaded. For example, in Niagara 2 is built with 8 cores. For example, we can take 8 core CPU of Niagara. Each core can handle 8 thread. Each core can handle 8 thread. This implies maximum ILP. ILP means instruction level parallelism and task level parallelism. TLP means task level parallelism, that can be exploited in Niagara is 64. That is, 64 threads can executed simultaneously in these processors, because 8 is cores and this is threads. One thread can handle 8 cores simultaneously. Hence this particular modern processor can execute 64 threads simultaneously. In 2011, Intel Core i7-990X, which reports 1,59,000 million instructions per second. Nowadays, the RISC means reduced instruction set computer processors. Those processors will replaced by x86 processors, that is multi-core x86 processors and many-core GPUs. And these x86 processors will dominate the modern data centers and supercomputers. Supercomputers are either HPC systems or HTC systems. And this GPU, that is applied in large clusters to build supercomputers in massively parallel processing also. That is, the large clusters will be developed by using these supercomputers in massively parallel processes. And the processor industry is now going to do research in asymmetric or heterogeneous chip multiprocessors. That means this processor will include the fat CPU and thin GPU cores in the same chip, that is one single chip contains both CPU and GPU. The next important one is multithreading technology, that is multiple threads will be executed on single CPU processor. In this diagram we are having 5 microarchitectures in modern CPU processor. This is architecture 1, 2, 3, 4 and 5. 5 different CPU architectures are there that exploit instruction level parallelism and task level parallelism, that is ILP and TLP, supported by multicore and multithreading technologies. And here we are having 5 independent threads: thread 1, thread 2, thread 3, thread 4 and thread 5. 5 independent threads of instructions to 4 pipelined data path. 4 pipeline data path: pipeline 1, 2, 3, 4. So all the processors are having 4 pipeline data path, which is otherwise called as functional unit. These 4 are called as one functional unit in each of the following 5 processor categories. And now let us see all the processors one by one. First one is 4-issue superscalar processor, fine grained multithreaded processor, coarse grained multithreaded processor, dual core, that is 2 core processors and simultaneous multithreaded processors. And we are going to see in detail about all these processors one by one. The first one is superscalar processor, that is 4-issue superscalar processor. 4-issue means a single thread with 4 functional units. It allows only one thread at a time, and all the other processors are multi-threaded processors, is 4-way multi-threaded over 4 functional data path. The next one is fine grained multi-threaded processor. This processor switches the execution of instructions from different threads per cycle. So this is one cycle. First thread will executed here, next it switches to next thread and next thread. Likewise, the execution of instructions will be switches from one thread to another thread per cycle. This is called as fine grained multi-threaded processor. The next CPU architecture is coarse grained multi-threading architecture, which executes many instructions from the same thread for quite few cycles before switching to another thread. That is, up to these cycles it will execute only one thread, and next it will switch to another thread for another few cycles. Likewise, the execution will be continued. The next one is dual core processor. In this dual core processor we can assume 2 processing cores. So here we are having, this is processing core 1 and this is processing core 2, each a single threaded 2-way superscalar processor. That is, each core will act as a separate superscalar processor. This is superscalar processor 1 and this is superscalar processor 2. And in the multi-core CMP, this is dual core. Suppose if it is multi-core, each core will execute the instruction from different threads completely. One core will accept one thread and that thread will execute completely, and another core will accept the next thread and that will execute all the instructions from the same thread completely. So each core will act as a separate superscalar processor. The last one is very powerful simultaneous multi-threaded processor, which is otherwise called as SMT processors. These processors will allow simultaneous execution of instructions from different threads in the same cycle. In a single cycle, it will allow the instruction from all the threads. This is thread 1, thread 2, thread 3 and thread 4. All the thread instructions will be executed in a single cycle. Up to this we have seen multi-core CPUs and multi-threading technologies from technologies for network based systems. In the university examination, you can expect this from 5 mark question. And thank you all of you.